Alright, what we're going to do today, do you remember doing the, let's do this. Let's draw a line here and a line here. What does it look like those two lines are? Yeah. Now they're parallel, aren't they? Good. So you guys catch on quick. Okay. And you got a transversal. So, if the lines were parallel, I'm not going to write all these angles in here, but let's just review really quickly on this, because today's lesson has to do with this stuff. If you had two parallel lines, so notice what this said. This always said, if the lines were what? Parallel, then... Oh, come on. It looks like an N, doesn't it? You guys are so picky. That was an I. I just kind of squished the... Is that better? You feel better now? All right, good. All right, here we go. If the lines are parallel, all right, then you had a bunch of stuff that was true. What was true? The corresponding angles were equal. The alternate interior angles were equal. The alternate, what? Exterior angles were equal. And the, what? Consecutive interior angles were what? Supplementary. Very good. A lot of people say equal, but they're supplementary. But this was all true only if what was true in the first place? If the lines were parallel to each other. So, when I first wrote this down, Cliff said they're not parallel because of what? Because I didn't have those little arrows there. Alright? So these lines right there, can I say that they're parallel to each other? No, I cannot. I cannot say these are parallel to each other right now. You with me? Okay. So this is review so far, but you'll see where it comes into play. The stuff that we're going to do today, it looks very, very close to what we had, done with this. But there's a slight difference. Before, when we did this, it was like section, I don't know what it was, 3.3 or 3.2 or something like that. When we did this stuff right here, we started off saying the lines are parallel. But this time, watch. Instead of saying if the lines are parallel, I'm going to start off with those other things that were my then part of my statement. What were the things? I listed like 4 of them. If their corresponding angles are equal, if the alternate interior angles are equal, and all that. So watch this. Let me ask you this. If the alternate interior angles, technically it starts off like this. Are we paying attention? Yes. You need to watch. If the alternate interior angles are equal, then what do you think must be true about the lines? That's right. Then the lines are parallel. I know, it looks like an M again. Sorry. Alright, the lines are parallel. Okay? If the alternate interior angles are equal, then the lines are parallel. So for instance, if I had 1 and 2, if I told you that 1 and 2 are equal to each other, what do you think must be true about line L and M? If I told you, now I don't know the lines are parallel right now, but I do know that angle 1 is equal to angle 2. So what do you think, Brooke? That's right, then lines L and M would be parallel. Do you see the difference between what we did earlier and what we're doing today? What we did earlier, we started off knowing, somebody wake up, Ravon. Okay, we started off knowing that the lines were parallel, right? In the other lesson. It was like lesson 3.2, I think. Everybody hear me? Mm-hmm. Today, we don't know the lines are parallel to begin with, but we do know what? We do know that angle 1 is equal to what? Angle 2. So if angle 1 equals angle 2, then what do you think we can say about these two lines? Then they're parallel. Then line L is parallel to line M. Exactly right. Does that make sense? Okay. I don't know why I started off with alternate interior, because what do we usually start off with on these? What was the first one? Corresponding. So let's do this. Let's say this is 3 and this is 4. I'm not going to list all those angles. Look at this. So if angle 3 was equal to angle 4, all right, do I have to do something here? We're not continuing, are we? I'm waiting for you. Thank you. Look at this. If angle 3 and 4 were equal to each other, what are angles 3 and 4? They're what? They're corresponding. So what do you think another thing would be? If what? If the corresponding angles are equal, then the lines are parallel. Let's write it a couple more times. What if angle 5 and angle 6 were equal to each other? What's the relationship between 5 and 6? They're alternate exterior angles. So what can we write down? If what? If the alternate exterior what? Angles, not lines. Yes, you did. Then what? Then the lines are parallel. Does that make sense? So we don't know the lines are parallel to begin with, do we? But we do know something about the angles. If the corresponding angles are equal, then guess what must be true about the lines? They're parallel. If the corresponding angles are equal, then the lines are parallel. If the alternate exterior angles are equal, then the lines are parallel. Remember, we don't know they're parallel to begin with, but we do know that this angle is equal to this one. All right? What's one more? If what? Consecutive what? Somebody help. The consecutive what? Interior angles, okay, are what? I forgot to put equals right there. Are equal? Are supplementary, right. If the consecutive interior angles are supplementary, then guess what must be true about those two lines? Then the lines must be parallel to each other. So let's do that. What number am I on now? Like 7 and 8? Okay, watch. Let's say this is 7 and this is 8. Now, I'm not saying they're equal to each other. If I knew that angle 7 plus what? Angle 8 equals 180 degrees. If I knew that. If this was true. Alright? So, for instance, if that was 130 and that was 50 degrees, do they add up to 180? Yeah. If that was 130 and that was 50, guess what must be true about those two lines? Line L must be what? Parallel to line M. Are you getting the difference between this? It's a slight difference. It's not a whole lot different, is it? All right? It's kind of like flipping it. It's taking an if-then statement. Are you listening? It's taking if-then and changing it. Instead of going, if the lines are parallel, then the corresponding angles are equal. What's it say? Boom. If the corresponding angles are equal, then what? The lines are parallel. Do you see what it's doing? Okay. That's called a converse. Listen to this. We skipped chapter 2, and they covered a lot of this in chapter 2, but watch. This is what they do in logic a lot. They do this. If P, then Q. Okay, this one. If P, then Q. P is the if part of the statement. If the corresponding line, let's start from the beginning. If the lines are parallel, then what? Then the corresponding angles are equal, right? Remember that? We did that on section, whatever it was, 3.2. But what if I switch it around? What if I do this? If Q, then P. This thing right here is called a converse. We're not going to get really deep into this. I'm just touching on it, okay? So, if Q, then P. So, I switch it around. So, I say, if the corresponding angles are equal, then the lines are parallel. Do you see how I just took the P and the Q and just switched places with it? All right. That's called the converse if I switch them around like this. This is the statement itself, and that's the converse. I'm not going to get big into this. I just wanted to just touch on that real quick. So at least you heard it. All right? And that's basically what we're doing today on this. All right? So what they're going to do is they're going to give you, let's do an example, okay? Let's pause this and I'll write an example for you. Yeah.